There you go. Maybe use 2 hands. There you go. Okay, and let it go, and I'm going to hold these. Now, did you see me push for a distance on this thing?
No.
Did you? No. I held this still. And if I hold this still, how the heck does that one go anywhere? I didn't push it. I didn't apply an impulse to that. It's very counter to Newton's idea, isn't it?
Mm-hmm.
And yet it moved.
Yeah.
Right?
Unless you consider the concept you just introduced, which is
exactly. Unless I consider that concept I just introduced.
And there's almost perfect elasticity to these balls. So they store the energy and they almost instantaneously release it.
Look at that. Now, what billion points of contact do I have energy drains?
Those chains.
Stupid idea.
So.
You know,
One's
really.
already starting to crack.
I know, they're really bad. Okay, and I actually did not realize how these bowling balls are inelastic. They actually give. And if you look on YouTube, there's a beautiful Newton's cradle made with sledgehammers.
Oh, cool.
Yeah, it's a much better idea. And the sledgehammers are hanging, and then the handles are on there, and it's lined up, and they bring one, and it was.
So my concept of elasticity is opposite to what you're telling me.
Right.
So, because I thought elasticity was the ability of something to return to its shape.
Right, right. And so don't even worry about that.
But I'm just curious.
Yeah, in physics, it's perfectly, Emily help me, or Maritza or anybody, if it's
These are elastic.
if it's an inelastic collision, it loses energy to heat. If it's perfectly elastic, it loses no energy to heat. Perfectly elastic loses no energy to heat.